So, welcome back. In our last session, we were discussing about inventory management of multi-echelon systems, where we have discussed a particular case of 4 installations, and we discussed that with the help of echelon inventory concept, we can apply at each of these stages the concept of basic EOQ model. Now, going further into the discussion and having a particular case, now let me have some data with us, and with the help of that data we will like to see that how multi-echelon model can be applied to that situation. Now, we have 4 installations 1, 2, 3, 4, and for each of these installations the setup cost, the KI, is 250, then 6, then 30 and 110, and the holding cost, which is HI, is 0.50, 0.55, 3.55 and 7.55. The demand of the supply chain D is 4000. This data is available to us. Now, with the help of this data, one thing which we were discussing in the last session, that is very much visible, that HI, that is the holding cost, as we are coming from 1 to 4 left to right in the supply chain, 0.50, 0.55, 3.55 and 7.55. So, you can see these holding costs are continuously increasing. So, therefore, this data is in line with what we have discussed. Now, as we said that to apply EOQ model in this particular case, we will consider the case of echelon inventory, not the installation inventory. These are the holding cost given for the installation inventory. So, now we will have the concept of EI, that is the concept of echelon holding cost, not the installation holding cost, and that is, in case of installation 1, it will be simply H1. For installation 2, it will be H2 minus H1. For installation 3, it will be H3 minus H2, and for installation 4, it will be H4 minus H3, and therefore EIs will be 0.5, 0.55 minus 0.50 will be 0.05, 3.55 minus 0.55 will be 3.0, and 7.55 minus 3.55, it means 4.00. So, these are the echelon holding cost, and now using the concept of echelon holding and the setup cost, we will have the formula for calculating the cost of variable cost of inventory at each stage. So, that is CI, that is for a particular stage in the supply chain, the cost of inventory will be D, that is KI upon QI plus EI QI by 2. This is the cost of inventory, variable cost of inventory at a particular stage. Now, when you use this formula and apply the concept of basic mathematics for getting the maxima minima, differentiate it, apply the maxima minima and then calculate the value of QI, because that is the only variable here. So, QI will be under root 2 D KI upon EI. I request all the participants to please practice this and get this formula on your own. I am directly giving you this formula here. Now in this formula there is a term which is very important for us in further calculation. This is this Ki upon Ei. Ki upon Ei. The value of Qi will depend on the ratio of K upon E. The ratio of K upon E will determine the value of Q. Now as we discussed in the last session, at stage 4 the quantities which we are getting are coming from 3, at 3 quantities are coming from 2, and at 2 quantities are coming from 1. So you need to have highest value for Q1, then Q2, then Q3, and the least values will be for stage 4. So that is the way. Now this ratio will play very important role in that case. Ki upon Ei, if the ratio of Ki upon Ei and the ratio of the next term, that Ki plus 1 upon Ei plus 1, if you see this comparison K upon E for 2 stages, ith stage and the subsequent stage, the successive stage in that. In this case, if Ki upon Ei is more than this, what will happen? Qi will be more than the next stage, that is desirable. Or the last possibility is it is equal to this. So in this case Qi will be equal to Qi plus 1. That is also possible in some cases, that if Q whatever is coming at stage 3, the same you are transferring to stage 4. Can you recall any supply chain situation where it happens that whatever you are receiving, the same you are transferring to the next stage? We can think of situation like cross docking. In cross docking, this type of situation may emerge, that whatever you are receiving at a particular stage, because cross docking we know we do not keep inventories. In cross docking we do not keep inventories. Whatever we are receiving, the same just by repackaging, the size of packets may vary depending upon the requirement. So cross docking is a kind of aggregation. So just to take you off from this discussion, in case of cross docking what happens, this is a place where cross docking is taking place, cross docking. So you are getting supplies from the manufacturers, so bigger packets are available A, B, C, and then we just make much smaller packets of A1 plus B1 plus C1, A1 plus B1, A2 plus C2, B2 plus A2 plus C3, of variety of combinations depending upon the requirement of the retailers. So we will just take the bigger supplies from the manufacturer which are more homogeneous, which are uniform, and as per the requirement of the retailer we will mix the supplies of different wholesalers to get the order of a particular retailer. So here whatever is coming, because stocking was the very point of cross docking is that you do not keep the physical inventories. You do not keep the physical inventories. So total input is equal to total output. On any particular day, total input is equal to total output. No inventories are there. So that is the situation where you can think of Ki upon Ei can be equal to Kith plus 1 divided by Eith plus 1, because in that case whatever is coming at a particular stage will be given to the next stage. So in such situations this type of calculation may come, but in most of the situations which we have discussed in our earlier examples, we will keep some kind of physical inventory. But nowadays it is of much significance. Nowadays it is much significance that none of the partner wants to keep the inventory, and for that purpose the systems of cross docking are becoming more and more relevant. And at the same time we also have the influence of just in time, and in just in type of systems we normally do not want to keep inventories, and therefore whether you talk of GIT or whether you talk of cross docking, in both these situations whatever is coming the same is going. No one wants to keep the physical inventory for a particular period at its stage. So in current examples, in current situations, it is quite possible that we have in practical cases more and more those types of examples where Q1 is equals to Q2, Q2 is equals to Q3, Q3 is equals to Q4 and so on. But if I talk of a traditional type of system, particularly in case like India, because many a times we see we keep inventory to avoid fluctuations of demand and supply, but in that case inventory becomes a slight typical issue where we need to maintain a particular level of inventory so that we can achieve the requirement of the customer and we can achieve a particular level of service. But at the same time, because of new types of challenges coming to us, we do not know how the demand will behave in the future, and therefore we do not want to keep higher inventories also. Like you see in our earlier case, the example which we discussed in the last session, at stage 1 the inventories were 8 times than the stage 4. Stage 4 was keeping just Q4 at any time, and stage 1 was keeping 8 times of Q4 in our last example. So now stage 1 is blocked, the stage 1 is blocked for 8 replenishment cycles of stage 4. So now stage 1, the point I am trying to say, the stage 1 will be able to consume this much stock of Q1 item in 8 replenishment cycles of stage 4, because in each cycle the quantities which are received by stage 4 are 1 by 8 time of Q1. So it may happen that after 2 replenishment cycles or 3 replenishment cycles, the demand all of a sudden changes, and therefore the whole system of inventory at 2, 3, 4 will be at a loss. So there is a challenge for the management also, that how to handle these uncertainties, and therefore we always look for some kind of optimum values, and therefore because more and more uncertainties are coming, you will find these types of cross docking examples. You will find that people believe in JIT, people believe in flexibility. Here you yourself can understand that I am waiting for 8 cycles, of stage 4, 8 times the order is procured at the stage 4, then a single order is procured by stage 1. So these 1, 2, 3, 4, 5, 6, 7 and 8, these 8 cycles of stage 4 represents the 1 cycle of stage 1. Now stage 4, after the third cycle, customer says no, we do not want this product, we want a different type of product which should have this much feature. But this stage 1 is still having this much inventory. So because now customers are not willing to purchase this product, the whole inventory in the supply chain, not only at stage 1 but at stage 2 also there will be some inventory, at stage 3 also there is some inventory, that complete inventory is at loss, and therefore this is a big challenge in front of us that how to address these issues, and probably more real time analysis will help us to reduce this type of relationship. We need to have more relationship that we can minimize this period. And you see, this is a case where only 4 such stages were there. If it is a even longer supply chain, in case of India, where our large number of population is living in rural areas, more than 60% of population is in rural areas, and in rural areas the supply chains are typically very long. Typically we have very long supply chains in the rural areas, and therefore this value may further increase. It is 8 times of your Qn, but if I talk of a rural supply chain, the values may further increase, and then this problem will be even more severe in that case. So therefore it is very much required that we need to have some better models, and we need to understand that what is the significance of this particular aspect, that you cannot have very high values of this n factor here, because more higher values you have that much rigidity in your supply chain. It will be difficult for your previous stages to change their product, because they have already stocked that much item at their stages. So we need to have a smaller values. We love a smaller values of this factor, so that our supply chain is more lean. There is less inventory at each stage, and that is what we are going to discuss in this particular case, that the inventory should be as less as possible, and the value of n is one important factor in that. Now coming further with respect to this particular problem, now here we see we have understood the meaning of k upon E, and now let us calculate this k upon E for these stages. Now let us calculate k upon E for these stages. So here it is 250 upon 0.5. So the value of this comes to be 500. Then 6 upon 0.05. This is 120. Then 30 upon 3, that is 10, and then 110 divided by 4. So this is 26.5. Now you see the values. 500, no problem, we cannot say anything about here, but the next value is less than this first stage. So this is okay. The next value is 10, which is much less than 120, absolutely okay. The next value is 26.5. Oh, not possible. This cannot be there. This value is not suitable, because this is more than 10, and I cannot accept, because if I take it, so the Q4 will be more than Q3, and that is unacceptable. Q4 more than Q3 is unacceptable. So this is a problem. Now to sort out this problem, we will do that, we will merge station 3 and 4. We will merge these two installations 3 and 4. The meaning of merging is that you will have same values of Q3 and Q4 finally, but for the sake of solving this problem, we will merge stage 3 and 4, and we will recalculate the values of k upon E after merging these. So when we merge these, you have stage 1, 2, and with this you have also merged stage 4. So you have new values of KIs, Ki will be 256, and now we have merged stage 3 and 4. So therefore this Ki will be 30 plus 110, that is 140. And similarly you will merge the values of Ei's also. So Ei will be 0.50, 0.05, and this 3 plus 4 will become 7. And now you again calculate K upon E. So this is 250 by 0.50, same 500, 6 upon 0.05, the same 120, and 140 upon 7, this is 20. So now you see 120 and 20. So you have a pattern that the ratios of K upon E in this particular case are following the required condition, and now we can apply this model. The results, because now we have reduced a 4 installation problem into a 3 installation problem. We have reduced the 4 installation problem into a 3 installation problem, and for that purpose the results will be, you need to calculate Q1 and Q2, but whatever we will calculate for this stage, the meaning is that Q3 is equals to Q4. Q3 is equals to Q4, that is the meaning of the result. There will be Q1 and Q2, and Q1 and Q2 will be the multiplier of obviously Q3 or Q4, whichever you say, but Q3 and Q4 will be same, or in other terms you can say Q3 is equals to, here the value of Ni Q4, this is equals to 1. This is how you can understand, and then you can go for calculation of Q1 and Q2. So now let us start solving the problem using this final table, and for that purpose first we will determine the starting solution. To initiate the problem, we will determine the values of Qi's with respect to these different 3 stations. So you have this formula, simple formula, and using this simple formula you can calculate the values of Q1, which will be under root 2, D is already given to us, that is 4000, into Ki, that is 250 upon 0.50, so on for Q2 and for Q3 or 4. So you will have these calculations, and these calculations will give you the values of this will come as 2000. The value of Q2 when you apply K upon E as 120, so this will come as 980, and for stage 3 and 4 this will be 400. So this is the initiation of the problem. This is the initiation of the problem. The first solution which we get, that is this Q1 is 2000, Q2 is 980, and Q3, Q4 is 400. But now you can see on your own, once we have calculated these values, and the meaning is Q3 is also 400 and Q4 is also 400. This means Q3 equals to Q4. Now 980 is not a direct multiplier of 400, and 2000 is also not a direct multiplier of 980. So the condition of that Qi is equals to Ni Qn is not satisfied. This condition is not satisfied here, because you are not able to achieve an integer value of Ni. That is first thing. And second relaxation which we discussed, that it has to be 2 to the power mi, that is even not satisfied, because none of them is even closer to this condition. So it means whatever we have done, this is the phase 1 of the solution process, or you can say this is the initialization of the problem. This is the initialization of the problem, that you got some initial values. Now my request to you is that, my request to all participants is that you calculate the total cost. You need to calculate the total cost on the basis of this. So you need to have this Ci, and if you do the total cost C, that is the sigma of Ci I equals to 1 to n. So you calculate this total cost. This is, you can say, is the lower bound of our solution process. This is the lower bound of our solution process. The meaning of lower bound is that our solution cannot have a higher cost. Lower bound means this is the worst solution. Lower bound means this is the worst solution, and the meaning of worst solution in our case is that this is the highest cost, this is the maximum cost you will incur in managing the inventory in this particular case. But now in our second phase, we will try to improve this value of C lower bound. This value of C lower bound, the total inventory cost का जो lower bound है, we like to improve this lower bound to a better value, and for that purpose we want to use these initial values. Now we want to achieve this type of relationship. The objective is to achieve this type of relationship, and when we have this type of relationship, probably we will have a lower values of total cost. We will have a lower values of total cost, and those lower values of total cost will be improved solutions, will give you the improved solution, and we will see for that purpose what to do. Now for that purpose, to initiate our phase 2 process, we will see first that this Qi, which is Ni into Qn, in this particular case we have to determine the values of Ni, and Ni's are, if I am at stage 2, if I am at stage 2, so there will be N2, N3, Q4. If I am at stage 1, so there will be N1, N2, N3, Q4, and if I am at stage 3, so Q3 equals to N3, Q4. So we have this type of arrangement. Now we can simplify this calculation by understanding this particular multiplying factor. By this particular multiplying factor, we can simplify our calculation. Instead of writing N3, N2 into N3, N1, N2, N3, I can simply write one factor Pi, and Pi is nothing but the multiplier of these things as per the stage. Pi value can be Pi, if I am talking of stage 3, it will include only N3. If I am talking stage 2, it will include N2 into N3. If I am talking stage 1, it will be N1, N2, N3. So in general, Pi will be nothing but be Ni up to N minus 1. This will be Pi, Ni into Ni minus 1 and up to N minus 1. And with the help of this, we can generalize the relationship as Qi equals to Pi Qn. So, this becomes our required relationship, that Qi equals to Pi into Qn. And now we will see that how to determine the values of Pi's and where to get the optimum values of Pi's for the solving purpose. And with the help of that, we will be able to determine that yes, now the solution is being achieved. So, now let us stop in this class here, and in our next class we will see the phase 2 of the solution process, where we will be determining the values of Pi's for different stages, and then we will see how to stop in that particular condition and how to complete this solution. Thank you very much.